So we've been working on understanding how sets of lines interact with each other. So one thing that's really important is all lines are straight, okay? All lines are straight. That's the whole point and definition of a line, okay? Now, we're talking about pairs of lines. So when there's more than one line. So if I have another line here, these two lines will never cross, okay? They won't touch, they won't cross, they won't intersect. They're called parallel lines. They have the same slope, up and over, 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 okay? And that is why they will never cross, all right? So intersecting lines, there's one line. And even if it is slightly different, the slope is slightly different, they're going to intersect at a point, okay? There we go, right there. So there's intersecting lines, lines that cross at a point. There's parallel lines, lines that never cross, and there's coincident lines. And that is when lines are exactly the same, okay? When two lines are exactly the same. I don't even know if it's gonna let me do it. So I'm gonna have to draw another line. It looks like one line because they're the exact same line. All right. So now let's look at an example. Oh, so let's look at our postulates. So there's the parallel postulate, and the parallel postulate says if there is a line, so we have this line right here, and a point that's not a line, then we have this point, so we can call it whatever we want. We can call it P, okay? We would normally put P a little bit closer, but beggars can't be choosers. Then there is going to be exactly one line through P, exactly one line through P that is going to be parallel to this other line right here. We can call this line L, okay? And there's exactly one line P through P that's parallel to L, okay? So I mean, that seems pretty obvious. That's why it's a postulate, all right? Now, a perpendicular postulate says we have a line and a point. Okay, we're going to call that to kind of a special point, but we're going to call it P. There's going to be exactly one line through P and L that is perpendicular. Okay, remember, perpendicular means there is a 90-degree angle, okay? We've made a 90-degree angle. So that is the difference between perpendicular and intersecting. This angle right here, oh, that's not really gonna work for us here, huh? This angle right here is not 90 degrees, okay? This angle is also not 90 degrees, and this angle is also not 90 degrees, and this angle is also not 90 degrees. But all of these angles are 90 degrees, okay? So that's the difference between a intersecting line and perpendicular lines. Perpendicular lines do intersect, but they have to intersect at that very important 90-degree angle. All right, so we have some roads in a town, And it says the given line markings show how the roads in town are related. Okay. So the first question wants us to name a pair of parallel lines. Well, we have a couple different sets of parallel lines. We have DE or CE, and we have BM or BF. Okay. So for A, okay, we can say that CD, and what we're going to want to do is we're going to insert special characters. Since we're going to be doing a lot of distance learning for the next few months, it's going to be really important that we kind of learn how to do math on the computer. And so this line right here, CD, is parallel to BM because it's never going to touch. Okay, we could have also called it MF. Also, you can see that these little arrows, they mean parallel. So another really good one is DM is parallel to EF. All right. So then we also have name a pair of perpendicular lines. Well, this guy right here, that 90 degrees gives it straight away that DM. And then what's really cool is when we insert our special character, it doesn't really matter which one we use here. That's the symbol for perpendicular. Look at it's a perpendicular, two perpendicular lines. DM is perpendicular to BN. Okay. Now, the third question says, is SE, so, or EF, same thing, right? This ray right here, is that parallel to AC or CA? I probably should have wrote it CA because it's also a ray. So let's investigate that a little bit further. They are not touching yet. But when I create a line that goes further for CA, and I create a line that goes further for EF, they do intersect right here. Okay. So are they parallel? No, because they intersect. Okay. Now for assignment 3, what you're going to do is you're going to Google search a city or a town, a map. I'm going to Google search San Francisco. It's one of my favorites. Images. Okay. And I like this one. It's a nice little map. And I'm going to drag it into my assignment. I drag it into my assignment 3. And I posted this assignment 3 on your Google Classroom. Okay. And what you're going to do with this is you're going to create your own parallel and perpendicular lines. So I've created a line. Okay. I'm going to make it a bit bigger and I'm going to make it a prettier color. So that street right there is one line, and it happens to be perpendicular. Bush Street happens to be perpendicular to that. And I'm making it 8 so I can really see it. And then I'm going to label my pink street, so parallel lines. My parallel lines are going to be pink. the same as my lines on my map. So I see another set of perpendicular lines that I really like. Lombard Street. Okay, I'm gonna make that blue and make it 8. Is perpendicular to Van Ness. I'm gonna make, I swear to God, I'm gonna make another line right here. It's gonna be 8, and it's gonna be blue. So Van Ness is perpendicular, see that 90-degree angle right here, to Lombard Street. So I'm making another text box, and it's going to be blue, perpendicular lines. Because we're looking at pairs of lines. There's not just one. There is 2. Okay. Now, if you're coming in San Francisco via BART, you're going to be on Market Street. And look how Market Street intersects with not only Bush, it also intersects with Van Ness, okay? So that's going to be my intersecting lines. All right. So any city you want, pull a map, draw some lines on it, okay? Parallel lines don't touch, perpendicular lines cross at a 90-degree angle, intersecting lines cross anywhere as long as they cross at all. If they're parallel, they don't cross. If they're not parallel, they will intersect anywhere, okay? So you'll find that in Google Classroom, and it is due on Thursday.